In this guide, we will be discussing mixing of concrete. Batching is a process of measuring the ingredients in batches for mixing. It is done either by weight or by volume. Volume batching is based on nominal mix and weight batching is based on design mix. Two common methods of batching are volumetric, as in case of nominal mixing, and weight batching, in case of design mixing. For all important concrete work, batching should be done by weight, and mixing by machine mixers. For very small projects, where mixing is performed on the site, the materials are usually batched by volume. Usually it is done through one-bag mixer machines. Under these conditions, accurate proportioning is very difficult. To achieve a reasonable minimum quality of concrete, it is usually less expensive to prescribe an excess of cement than to employ quality control. Volume batching. The ingredients are batched and proportioned based on volume. It is achieved by using a constructed gauge boxes, called for mass. For proportioning, cement is measured by bags and water in liters. The quality of concrete may differ because of bulkage of fine aggregates, and therefore, concrete may not be uniform and consistent. Volume batching is performed by using gauge boxes of inside dimensions of 350 mm by 400 mm by 250 mm. The box volume is 0.35 cubic meter, equivalent to volume of one bag of cement. For nominal mix, which is 1:2:4, use 1 bag of cement, 2 boxes of sand and 4 boxes of coarse aggregate and mix them together. Weight batching. The ingredients are batched based on weight of individual components. The mixing is performed by a wide variety of equipment. Water for mixing is weighed out precisely as a function of the weight of cement used for each mix proportion. Hence, uniform water-cement ratio is maintained. Each batch is weighed, which makes it easy to detect overruns or incorrect dosages. Concrete is of uniform and consistent quality. Grading of coarse aggregates and fine aggregates shall be checked at frequent interval to ensure that grading meets the requirement of mix design. Amount of added water shall be adjusted to compensate for any variations in moisture content in aggregates. No substitution of materials or change in the established mix proportions shall be permitted. Volume batching may be allowed only where weight batching is not practical. The weigh batching process. Cement weighing. The cement bins or silos should be large enough to cope with all types of concrete mixes. Bins should have steep angle walls so that cement dust to stick to the surfaces. For manual loading of cement, load cells weigh individual bins in which cement is emptied. For batching plants, screw conveyors transport cement to the mixing drum. Water batching. The plants are equipped with a water batch weight, or a water meter. As water content is a key component to the strength of concrete, ensure proper functioning of the water measuring devices. In automated plants, the microprocessor adjusts quantity of water present in the surface of aggregates. Aggregates weigh batching. In 3-bag mixer machines, bin have load cells, and aggregates are added manually in the bins. In batching plants, aggregates from bins are unloaded pneumatically into weigher below, through a batching gate. The required amount is then conveyed to the concrete mixer. Mixing arrangement. The concrete production plant uses 2 types of mixing arrangement. Batch mixers. It produces 1 batch at a time. They use free-fall methodology of mixing components. Continuous mixer. These are power mixers as in batching plants. The concrete components continuously enter at one end, as the fresh concrete exits the other end. Batch mixers. 2 main types of batch mixer, distinguished by the axis of rotation of the drum. Horizontal, drum mixers, or vertical, the pan mixers. The pan mixers may have either the blades or the pan rotating around the axis. Batch mixers, horizontal mixers. Also called drum mixers. The drum mixers have a drum, with fixed blades, rotating around its axis. Types are reversing drum, as in self-loading mixers, Ajax, and 3-bag mixer machines. Tilting drum, as in 1-bag mixer machines. Non-tilting drum, in which mix is the materials are added at one end and discharged at the other. Batch mixer, pan mixers. Power mixers, as in batching plants. The ingredients are mixed by the moving arms within the mixer. Gives better homogeneity and consistency. Batch mixer, continuous mixers. The materials are continuously fed into the mixer. Upon mixing, the concrete is discharged from the other end. They usually have screw-type blades rotating in the middle of the drum. Weight batching versus volume batching. Ingredients are batched or proportion based on weight. Use of weigh batching. Quality is uniform and consistent in this method. This method is costlier. However, this method is more precise method. Ingredients are batched or proportion based on volume. By using measuring box or say firma, we can experience variations in quality due to inconsistent mixing. This method is cheaper and less precise. Loading period. The mixing time is defined as the time elapsed between the loading of the first constituent to the final discharge of the concrete. The loading method includes the order of loading the constituents into the mixer and also the duration of the loading period. The loading period divides into two parts, dry mixing and wet mixing. The duration of this period depends on how long the constituents are mixed dry before the addition of water and how fast the constituents are loaded. Loading phases. Dry mixing is the mixing that occurs during loading but before water is introduced. Wet mixing is the mixing after or while water is being introduced, but still during loading. Loading sequencing. The loading period is important because some of the concrete properties will depend on the order in which the constituents are introduced in the mixer. Later addition of water and admixtures helps better spreading of the cement among aggregates. Wear and tear, cleanness of mixers. In determining mixer efficiency, the main focus should also be on getting homogeneous concrete. Usage of mixer leads to wear of the blades, and the buildup of cement paste or mortar. This will lead to improper mixing. The concrete mixer should be thoroughly cleaned at the end of each day of operation and the blades and or scraper changed on a regular schedule. Summary: mixing is a complicated process that is affected by the type of mixer, the mixing cycle, and loading methods. Also, a lot of electrical energy is consumed in the mixing cycle. Ensure proper mixing is done to produce a high-quality concrete.